Hello everyone. This is day one of writing 15 smart contracts in 15 days. So, this is day one. So, we'll start slow. We'll understand some concepts related to blockchain, right? We'll actually we'll get a brief overview on blockchain. We'll understand what are smart contracts and actually we'll understand what is hard hat, right? So, starting and keeping it simple, what is a blockchain? So blockchain is just a decentralized network of blocks, right? Now, what does this term decentralized means? Like, if you use any decentralized application, your data is not being owned by someone, right? Your data is not being used, is being owned by someone, right? Whereas in a centralized application like Instagram or Facebook, your data is being owned by the company who has built that software, right? So yeah, this is pretty much about what a blockchain is. Uh, I'm not going too deep into this concept, right? I'll create a separate video for this. Then the second concept is smart contracts, right? Now, what is this smart contracts? So smart contract is just a piece of code which runs on the blocks of blockchain, right? It is just a simple piece of code which performs some functions onto blockchain, right? And the third term is hard hat. Now, in order to run this piece of code onto this blockchain, you need to deploy this smart contracts onto this blockchain, right? So how will you do so? And firstly, you have to develop a smart contract and run it onto your local system as well, right? So how can you do that? You can do that using Hardhat, right? So in Hardhat, you can write test cases, you can write a script to deploy your smart contract onto this blockchain, right? So yeah, this is pretty much an overview on what we are doing and how the things work under the hood, right? So now let's get into writing some piece of code, right? So yeah, this is day one. So we'll keep it simple and today we'll just write a smart contract on uh, a piggy bank, let's say, where a user can just can just deposit their ethers and can actually withdraw it whenever they want, right? So yeah, let's get into the coding. So yeah, this is our screen. Okay. So let's get into the coding part. So over here, I have set it up a project using Hardhat. In case if you don't know how to set up a project using Hardhat, do let me know. I'll create a separate video for that. Just to save time over here, I have set it up the project already over here, right? So we are having a folder called contracts, and I'm having a folder called tests. Okay, where in this test folder, in this file, I'll be writing all the test cases using Hardhat, and over here, I will be actually writing my smartphone, right? So yeah, let's get into that. So in order to write the smart contract, you just have to give a license agreement first. So SPDX, the license identifier. Then you actually have to mention that what version do you want your Solidity smart contract to compile with. So that's done using Pragma Solidity. The version which I will be using is 0.8.28. So this goes over here. Okay. And now using contract keyword, you can actually define a smart contract, right? So this is Copilot is giving me suggestions. Okay. So PiggyBank. Okay. So this is how we this is how we define our smart contract, right? Now we are writing a smart contract just to deposit the ethers into our smart contract, and actually the user with the wallet address can actually withdraw it at any time, right? So for this we need to store their wallet addresses mapped with their account mapped with the ethers amount they are having in that wallet address, right? So we can do that using mapping addresses. Yeah, it's correct. Mapping addresses, event public balances. Okay. So what does this line means? This line means the that the wallet address of the user is being mapped with the amount of ether it holds, right? Now we have this mapping with the amount and the wallet address. Now we can actually write a function to deposit some ethers into that account. So yeah, function deposit public payable. Okay, this correct. This is correct. Okay, and we will also be having a function to not to withdraw. I need a function to check balance, right? Check balance. Okay. So now let's understand what this code means. Function deposit public payable. Okay. And it requires message.value. Now what this message.value means? Message.value means message.value is the actual amount of ethers which the user with the specific wallet address has deposited to this contract, which must be greater than zero. And if it is not greater than zero, this message will be popped up, which is deposit must be greater than zero, right? Now, what if this required case passes? Then the amount, then the amount on this address will be incremented by this value, right? So how can we do that? This is a mapping, so we'll be doing this using balances. Message.sender. Now, what is this message.sender? Message.sender is a wallet address which is being used to run this smart contract, right? So yeah, so we got that address using message.sender. And what is message.value? Message.value is the value which is to be deposited using this user into this smart contract, right? Okay. Then we have a function to check the balance. Okay, this is a public function and it returns a unsigned integer, right? So yeah, over here we have just returned this balance of this user, right? Message.sender. Okay. So this is just a code to deposit some ethers into the smart contract, right? And so let's quickly write a test case for this. So for writing test case, we'll be using Hardhat and Chai. Now, what is Chai? Chai helps you write some exceptions in your test cases, right? So how to define that? Const except equals to required Chai. Okay, required Chai, and now we also need ethers. Uh, const exe. Oh, sorry. Okay. Now, what is ethers? Ethers is a library on Hardhat which allows you to interact with the Ethereum blockchain, right? Now we will write the test case for this. So how can we do that? We can do that using describe. We are writing this for the piggy bank. So piggy bank, okay, piggy bank and function, which is a fat arrow function. Oh, sorry, not like that. Okay. Now we have to write before each case for this. So what is before each case? Before each case is a piece of code or a test case which runs before before each and every test case when it is executed, right? So before each is okay. So before each, we mark this as async function, async. Okay. And now we actually need to connect our smart contract to this test case, right? So, mm, not that. We'll first actually define some variables. So I'll define a piggy bank variable. Then I will define a variable with the sender. Okay. Yeah. Not receiver. And over here, now I need a specific address for the sender, right? So how can I get that? I can get that using getSigners function. Now, what does getSigners function do? It will give you a dummy wallet address loaded with some ethers into it, right? So how can I do that? I can do that using sender await ethers of getSigners. Okay, right? Now we actually have to connect our piggybank.sol smart contract with this test case. So how can we do that? We can do that using a function called getContractFactory. So we'll quickly do that. Const piggybank await ethers dot getContractFactory piggybank. Right. So over here we have connected our smart contract with the the test file which we are writing over here, right? And then we'll just simply deploy that. Okay. Yeah. Await piggybank dot deployed. Okay. So now the before each case is done. Actually, we don't have to write this. Okay. Now we will actually write the test case for this deposit function. Okay. So you can write a specific test case using it keyword. So it, and you can write a message for that. So deposit, which is an async function, arrow function. Okay. Now over here you have to write your test case, right? So yeah. Now we will actually just deposit amount of ether into the smart contract. So await PiggyBank deposit. Okay. So yeah. So uh, what it does is it takes this deployed smart contract and actually runs this deposit function. We are able to get this function because we have defined this function over here, right? If I don't define this function over here, I won't be able to run this deposit into this. Then we have passed a value using parse ether, right? I have passed one ether over here as a value because over here we need a value greater than zero, right? So yeah, so let's quickly run this. Okay, so I have written the test case for deposit function, right? So over here we are just passing the ether value into our smart contract using this variable where the before each case has deployed our smart contract, right? So we have passed a value which is greater than zero, that's one, and we are actually checking the balance. I can also log it as well. So console.log balance. So it will actually it will actually return us the balance corresponding to that wallet address, right? So let's just run this smart contract, this test case, sorry. So yeah, new terminal and navigate to the directory npx hardhat test. And yeah, we got the balance and we got our test case passing. So what just happened over here? We actually the deposited one ether into our smart contract, right? Now we'll actually write a function to actually withdraw this amount of ethers. Now, what is this value? This value is in way. One ether equals to 10 raised to 18 way. So it's being returned in way, right? So let's just write a function to withdraw. And now what does this function do? It will be taking a withdraw amount. It will be taking a withdraw amount as the parameter, right? And it will allow the user to actually withdraw that amount of ethers from our smart contract, right? So yeah, over here it ends with a semicolon. Okay, so we are having a withdraw function which has a parameter called amount. Now, what is this actually? A required case where the balance of the account should be greater than the amount which the user is trying to withdraw. If it's not, it will be returning insufficient balance. And it is obvious that the amount should be greater than zero. If if both these cases pass, then this much amount will be deducted from the account of that user who's running the smart contract, right? And we have marked this user as payable because they are actually they are actually getting the ethers out from the smart contract. So we have marked this as payable and will transfer the amount to this user, whichever amount is mentioned over here in the parameter, right? So let's just write a test case for this withdraw function. So it withdraws withdraw then async async fat arrow function. Okay, so await PiggyBank deposit values dot ether. Okay, not deposit actually. I have to withdraw, right? So how can I do that? I can first. Okay, yeah. So I just fixed the test case. So over here, we first have to deposit into the account of the user who's running the smart contract, and then we can actually withdraw using this withdraw function, and then we'll check the balance which is there in the account of that user who's running the smart contract, right? And it should be equal to this amount, right? So let's run this test case. So npx npx hardhat test. Oh, sorry. I have to do this in this directory, npx hardhat test. So yeah, over here, both the test cases are passing. So let's check the value. So I'll comment this test case out and I will check balance. Okay. I will just log this balance. Okay. Semicolon and then run this test case. So yeah, over here it's saying this v value, right, which is there in the count of this user, right? And then if I don't deposit this, what can happen, right? It says insufficient balance, so we have to run this. Okay. Okay, so what over here is happening that we are not able to actually keep the log of the amount which is being stored into our contract, right? And we are not able to withdraw it correctly. So why is this happening? It's happening because we haven't connected this PiggyBank.Sol smart contract with this sender's wallet address. So how can we do that? I will just connect it with sender.deposit. Okay, sender, and I will copy this. Okay, right now, first we'll First, we'll run this deposit test case and then we'll run this withdraw test case. Right. So, okay. I will just comment it out. PiggyBank dot withdraw dot sparse ether. Okay. PiggyBank dot connect sender dot withdraw. Okay. So now actually when we will deposit it from here, we can actually withdraw it from this test case. Right? So let's first comment this out and run our deposit wallet test case. Yeah, so it's passing. Um, let's just log the balance as well. Balance. Okay. Now just run the test case. Yeah, so I'm getting the balance. Now I will comment this test case out and actually run this withdraw case and withdraw the withdraw. Let's withdraw the whole ether. Right? There should be equal to 0. Yeah. Okay. hmm Okay, I have to give 0.5 over here and 0.5 over here. What is it saying? Okay. Yeah. Okay, so I have to first connect this. It won't happen if I won't connect this sender first and deposit some amount of ethers into that smart contract. So yeah, first we'll just connect the user and run the deposit function and just deposit 1 ether to their account. Yeah, yeah, and the withdraw test case passed. Okay, so yeah, this was the video for today. From tomorrow, we'll also write the deploy script for deploying the smart contract as well. Okay, so thank you.